Question number 1. We need to solve for the variable m, as it's the only variable here in the equation. So we're going to start by using the distributive property here. Negative 3 times 2m is negative 6m. Negative 3 times 5 is negative 15. Still have that minus 4m and equals 25 over on the other side. We're going to combine these like terms right there. Negative 6m and a negative 4m together make negative 10m. Still have that minus 15 and the 25. Now let's get rid of the 15 by adding 15 over onto the other side. Leaves us with negative 10m. The other side ends up being 40. We're going to finish this out by dividing by negative 10. Divide by negative 10 and we get m equals negative 4. We're going to start question number 2 by distributing over on the left and the right hand side here. 4 times x gives us 4x. 4 times negative 7 is negative 28. And on the right hand side we have negative 4 plus 2 times 3 is 6 and 2 times x is positive 2x. From here we can start to get our like terms together. We got negative 4 and a 6. That will give us a 2. So rewriting, we get 4x minus 28 equals 2 plus 2x. Let's subtract the 2x to get it over here on this side. 4x minus 2x is 2x. So we have 2x minus 28 equals 2. Add that 28 to both sides to get rid of that, and we get 2x equals 30. We'll finish this out by dividing by 2, and we end up with x equals 15. Question number 3, we're going to distribute again on this side. Negative 4 times 2m is negative 8m. Negative 4 times 5 is negative 20. Still have that minus 3m. And a 35 over on this other side. These two are like terms. That gives us a negative 11m. Still have the negative 20 and the 35. Now all of our like terms are on opposite sides, so we got to get that 20 over to the other side. We're going to undo the subtraction by adding 20. That leaves us with negative 11m on the left. 35 plus 20 is 55. We're going to divide by negative 11 to get m by itself, and we end up with negative 5 on that side. Absolute value equations are solved by splitting up into the two scenarios, both positive and negative. We need to isolate the absolute value first, but that's already taken care of right here, so we don't have any work to do there. So we can go ahead and split it up straight into our two situations. So our first one is 11x inside the parentheses could be equal to positive 44. That would solve it. Or 11x inside those absolute values could be equal to negative 44. Both of those would get us the proper value. We're going to divide by 11 to get rid of that on this side. We get x equals 4. Divide by 11 on this one as well, and we get x equals negative 4. Since both of those solutions work, we're going to give it an OR. Either one of those would work. On this one, we have absolute values, so we have to set up our two scenarios. We can have negative 4x plus 22 inside those absolute values could equal 108. That would give us one solution. And negative 4x plus 22 could give us negative 108. Solving these, we end up subtracting 22. Subtract 22. That'll give us negative 4x equals 86. Divide that by negative 4, and we get x equals negative 21.5. On the right hand side, we're going to subtract 22 again, same steps as we did before. We get negative 4x equals negative 130. Finish this out by dividing by negative 4, and we end up with x equals 32.5. You could leave both of those as decimals if you wish, or fractions would be acceptable. On this particular one, we need to isolate the absolute value first. We can see that that absolute value symbol is not by itself over on that left-hand side. So we're going to do a couple of steps to get ready for that to start with. So we're going to subtract 8. Subtract 8 over on this side. That gives us negative 5 times the absolute value of x plus 16. Over on the other side, we end up with 59. We're going to divide by negative 5. Divide by negative 5 on that side. We end up with the absolute value of x plus 16. That would be negative 11.8. Now at this point, we're going to take a look at this. This is a scenario where we don't have to go any farther. If this was a positive number, this would work out just like the previous two, where we had two scenarios and we would solve both of them. However, when we talk about absolute values, it is not possible to get an absolute value to be a negative number. And so since we have the absolute value trying to equal a negative number, that makes it so it's not possible to solve. So this one ends up being no solution. If you set up the two scenarios, then it would give you two possible solutions, but neither of those would work. So this one's a little tricky. It ends up being less work than the others, but we have to stop and analyze that to realize we shouldn't move any further. Now we're getting into some literal equations where we have multiple variables. So we have to pay attention over here to which variable to solve for. This one we want to solve for y. The y is right there. So we're going to get rid of the terms that do not have the y first. That would be the px. We're going to get rid of that one from the left-hand side by subtracting px. Any number subtracted by that same number ends up being 0. So that is gone from that side. So we'll subtract px over on the other side. That leaves us with by on the left-hand side. And these are not like terms on the right-hand side, so we just leave them separate. We're going to have g minus px. It is okay that we can't combine those. All we have to do now is get rid of this b, and since it's being multiplied to the y, we can undo that with division. So we're going to divide by b. On the right-hand side, we need to make sure we divide everything by b. So we get g minus px over b, and we're finished. We can't simplify this any further. Nothing is like terms to combine, and we don't know what that division ends up being. Kinetic energy. We're solving for m on this one. This is a nice physics formula. That means the m right here needs to be isolated. So we have to get rid of this 1/2. We have to get rid of the v squared. Now if you take a look at this notation on the right hand side, the 1/2 is being multiplied to the m, and so is the v squared, so we can undo everything with division. We're going to divide by 1/2, and we know that dividing by 1/2 is the same thing as multiplying by 2 over 1. We multiply by the reciprocal. Over on the left hand side, this is going to work out nicer, because when we do that, 2 over 1 is just 2, and 2 multiplies nicely by the k. So 2 times k is just 2k. Love it. Over on the other side, this ends up being 1, so we're left with mv squared. We can get rid of the v squared all at once by dividing by v squared. We'll divide this side by v squared, and we end up with m by itself. Over on this side, we have 2k divided by v squared. Again, no like terms, so we just leave it like this. Solve for y. We've got y's on both sides here, so let's get them on the same side so that we can get them together. I'm going to add the 5y over to the other side. I chose to go that direction because it gets it away from that 15. So we have 2xy and a 5y. Now, normally we would combine these y's, but they are not like terms because of this x variable right there. So this question, we're going to have to factor out the y's. So we're going to divide that out, factor it out. We end up with, inside the parentheses, we have 2x left with our first term and a 5. And we have the y left outside. Now I like to double check that I did this correctly, so I'm thinking if I was to distribute this back in, would I end up with the same thing? And we have y times 2x would be 2xy, the y times the 5 would be 5y, so we would end up back where we started if we distributed that. Now I don't want to distribute it because our next step, we're going to undo this multiplication right there by dividing. We're going to divide by 2x plus 5, since that's all together in parentheses and being multiplied. We can do it to both sides and get rid of that whole piece all at once. because 2x divided by plus 5 divided by itself ends up being 1, and it's gone. So that leaves us with y over on the right hand side, and on the left hand side we have 15 divided by 2x plus 5. And the y is now by itself, so we are finished. This one we've got x that we're solving for, and we can see that the x and the x, these are on the same side, so I don't have to move them back and forth at all. But they are not like terms because we have that y over here in this first term and no y in the second term. So we're going to have to factor like we did on the last question. Before we factor though, I like to get rid of all of the terms that do not have the y. That would be these two right here. So let's get rid of them like we've been doing with the other questions. We're going to add 3 to this side. We have negative 2xy. We have 6x still left. We have a negative y, and over here 6 plus 3 is 9. Now we're going to get rid of this negative y by adding y. Get that over here. We have negative 2xy plus 6x equals 9 plus y. Alright, now we have terms with just the x's over on the left hand side. So we are ready to factor that x out of here. We end up with x. Our first term has a negative 2y left in it. The second term has a 6 left in it. And over here we have a 9 plus y on the right hand side still. Just double checking like we did before, if I was to multiply that in there, x times negative 2y is negative 2xy. Awesome. So that worked out. X times 6 is 6x. So that also works out. Awesome. Okay, we're not going to distribute it in. We're going to divide this out. We're going to divide by negative 2y plus 6 to get rid of that last piece. Divide over here by negative 2y plus 6. And this divided by itself ends up being 1. Leaves us with x on the left hand side. Over on the right hand side we have 9 plus y divided by negative 2y plus 6. The x is now by itself, so we are finished. We're trying to find the number of hours of labor spent repairing the bicycle. So I'm going to say H is our hours of labor. What's related to hours? Let's see, we've got a cost here, total cost. We've got a parts cost, that's going to be paid once. And then over here, that's what's related to the hours. And so we definitely need to connect that right there. So if I was to write this out in a sentence, I would say that the cost, the total cost, would equal the parts cost plus the labor cost. And we know the total cost, it was $372. We know the parts cost, it was $120. That just comes directly from the question. The labor cost we're going to have to calculate by taking this $42 per hour and multiplying it by the number of hours that we get. That's just 42h. Now we have an equation with h in there, and if we solve for that h, we'll figure out our hours of labor, which is the point of the question. So we're going to solve this by subtracting 120 from both sides. Subtract 120 over here. We end up with 252 and 42h. Finish this out by dividing by 42 on both sides. 252 divided by 42 on the left hand side is what we need. And that gives us a total of 6. This equation is what should go here for this equation in that blank, and the solution I'm going to write h equals 6 and with the label of units, hours. Next, we're trying to take a look at wages. So it says, what is your hourly wage? All right, we know our total pay. We know our pay from tips. And the remaining amount was from your wages. Cool. So there were 26 total hours. If we take that 26 and multiply it by our wage, then we get the amount of money that we make from our hourly pay. All right, so we're going to have our hourly pay, which would be 26 times W, I'm going to call it. Let's label W. W is our hourly wage. So 26 hours times that hourly wage will give us our wages for all the hours that we work, the money. We know that we got $311.28 from tips. So I'm going to add that $311.28. And over on the other side, we have our total pay, $372.38. So if we take our pay for our hours, our pay from our tips, that should get us our total pay. That's our equation. That's what I want you to write here. All right, we're going to solve this one just like we did before. So we're going to subtract 311.28. That gives us a total of $61.10. Over here we have 26W. Let me fix that typo there. 26W, divide by 26, divide by 26, and that should give us our wage. And that ends up being $2.35 per hour. So our solution, our wage equals 2.35. The units are going to be expressed by putting that dollar sign there. For this last question, we are to find the value for x and then find each angle measure. We need to make sure we do all of that. This information right here is going to be essential for us to write an equation for this situation. Sum means that we're going to add things together, and as you can see, it's telling us to add all of the angle measures together. So we're going to take each of these angle measures and add them up. That gives us 120 plus, here's 100, plus, here's another 120, plus, here's another 120. All right, and then we're going to add these. So I'm going to add the x plus 10 and the x. Doesn't really matter which order you add them up, because summing is all right in any order. But we got it all added up, and we equal 720. So we're going to combine some like terms. All of these numbers here are like terms. So we got 470 all together with those numbers. And then the x's are like terms as well. So we get plus 2x right here. On the other side, we get 720. Continuing, we subtract 470 from this, subtract 470 from that, and we end up with 2x on our left-hand side equals 250. Finish this out by dividing by 2, and we get x equals 125. Now let's write down the measure of our angles, and we have a lot of them that are already given to us, so we're just going to write those down. This angle is x, and we know x is 125, so we now know that angle is 125. Over here we have x plus 10, so we got to plug it in. 125 plus 10 is 135. So we now have all of the angles, but let's add them together just to make sure that they sum up to 720 after all. Add those all together, and indeed they end up being 720 degrees. So we have correctly solved this equation. Thank you everybody for watching, and good luck on the test.